Alright, time for another draftphysics.com, debatephysics.com also, but can't get these people to interact in any useful manner. Counterpoint kind of thing is all you're really looking for, and they're just not up to it. So anyway, this, whatever, twattist of physics, she, it's just the generic physicists. They learn their catechism and then they go out into the world and just preach this crap. And it's just a religion because the amount of evidence they're drawing their conclusions from is, almost non-existent. And certainly with all these elemental statements about like kinetic energy, where the theory says something quite preposterous, like it takes 25 times the fuel to go 5 times as fast. It doesn't show up anywhere in reality. Okay, it's part of their theory, but they never even test it. Light is bent by gravity. They say it, they're sure of it. And they won't even bother using any of their telescope technology in space where there's 400 times better resolution to test that theory. Nothing. So they just preach their religion. And frankly, the fact that they are so uninterested in compiling evidence kind of is like the religious people. They know there isn't any. They know they can't prove their crap. And so they resort to just a bunch of, words. And people are dupes and they fall for it. It surprises me, frankly, that people are as gullible as they are, but they are. Just a fact. So I left off here at about 5 minutes. This is part 2, if you didn't notice. So she's now going to explain how, okay, the accelerometer is the spring, and it's going to measure something, and, they really don't get it. That they have to really analyze how the thing works to understand what it can or can't measure. But anyway, so leave us play the video, hopefully.
What's going to happen with the spring? It'll expand so long as the...
Right, but it won't expand evenly. Okay, so there's a technical reality. So as the rocket is attempting to accelerate another mass, it's going to have to use some of its energy. So let's say the rocket was going a constant speed and you just added the spring, you hooked it. Well, then all of a sudden the rocket can't go quite as fast because it's got to spread the force it has. It has to take the quantity of motion it has and it has to spread it over more mass. And so it's going to dilute how much peanut butter is on the bread. And the fact is that the spring is doing the same thing. The molecules of the spring here at the beginning, at the part you connected to, just like your body getting pushed back up by gravity, there's going to be a huge unevenness. The part here is dragging all this mass behind it, and the part here is dragging that mass behind it, and so the spring is going to expand unevenly. It's not going to be an even expansion.
velocity of the rocket changes. Why is that? Well, as Newton taught us...
Yes, so Newton didn't teach us. Newton just made observations and explained what reasonable things he could conclude out of those observations, and he was very careful not to create a religion out of science. And scientists, the day after Newton was dead, said, oh, the hell with that theory. No, science should be a really good religion.
Force equals mass times acceleration.
So that's not Newton, so it's just a lie. At least there's one scientist that says that. The only physicist who will admit that that's not what Newton said. What Newton basically said is F equals E. He basically said F equals the stuff you're talking about, quantity of motion. It's exactly correlatable. You want to go twice as fast, you need twice the force. You want to go 3 times as fast, you add 3 times the force. And they perverted it into this F equals ma thing because they're going to pretend the acceleration is a squared quantity. They're going to say the acceleration is 9.8 meters per second squared for some dopey reason, when it's 9.8 meters per second per 1 second, not squared seconds. So again, it's just such a simple perversion And that's all this is, right? It's about a pervertiverse. They deliberately pervert what was established as a truth, pretend that somebody who established that truth, who had some kind of credibility, said things he didn't say, so they can prop up this religion. So it really is F equals E, F equals weight, F equals momentum, F equals thrust. F equals all of those things, and are calculated by just simply recognizing that everything in the universe that has any energy is basically a mass moving a velocity, period. Nothing else, no more complicated. That's quantity of motion. That's what Newton said. That's what Newton understood. And these perverts, these pervertists, she's a pervertist, play this game of let's lie about Isaac Newton.
So if you accelerate one end of the spring, that creates a force, and that force stretches the spring.
So the force was created by the mechanism you use to accelerate that part of the spring. So again, there's just no point in pretending, okay, that the force isn't in the motion itself, the big mass moving. The force isn't in the form of the little stuff moving, the speed of light kind of force. That's not what you're introducing. Yes, that's ultimately what creates all motion, because it's all motion of electrons and protons, and they're exchanging force. But the fact is that this isn't moving by a gravitational force that's going to move something evenly. It's being moved by something that's going to move it unevenly.
You can measure how much it stretches, and from that you can calculate how much it will accelerate.
Right, but the only reasonable way to do that calculation is to put a mass on the end of the spring, and then see how much the spring moves, and just discount the spring's mass. So make the spring very light compared to the mass on the end of the spring, and that way when you do your calculation, it will only be a little tiny bit off, instead of a lot off.
Yeah, I know this isn't exactly rocket science.
Yeah, brother. And even rocket science isn't rocket science, right? So again, they sit there and pretend this is something to do. That flame coming out of the bottom has something to do with kinetic energy. And there's this tremendous amount of kinetic energy coming out, and blah, 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 blah. And all there is Newton's equal and opposite reaction. There's a certain amount of momentum going out of one end of the rocket, and the rocket, in a response to the fact that it gave away a bunch of that way, goes that way, because it gave away that way, kind of obviously, a whole bunch of that way.
Even if it is, but bear with me for a moment. This example tells us three very important things. First, you can use a spring to measure acceleration.
Right, but you have to recognize what springs are and what they're capable of. Okay, and so the whole idea is to prevent the spring from expanding all the way, right? Because we know if we let it expand all the way, we're not letting the energy out. So you have to keep the spring under constant tension, and that way you can get reliable measurements. And even if it's a little bit uneven in terms of how it collapses and expands, it won't matter, okay, because it's under a constant tension.
It's not the only way to do it, and maybe not even a particularly good one, but
well, who cares? So yes, so fine. Again, measuring acceleration for what purpose? There's no other purpose than to just acknowledge the fact that to accelerate it, I have to use a force. And how much force do I have to use? Well, exactly the amount of force that equals the amount of momentum I'm going to derive from it, nothing else. There's no squared functions.
It works, and acceleration is measurable. Second, you cannot, of course, use the spring to measure the velocity of the rocket.
Of course you can. So again, this is the nonsense part, right? That somehow velocity isn't a real thing, okay, because it has a direction or something. And so you have to use some notion of speed or something, right? Because we have to play some idiotic game where they invented some concept of scalar energy, that somehow there's energy and it doesn't have a direction. Like somehow there's a photon and it doesn't have a direction, or somehow it's just a nonsensical notion. It's not true. It's just made up. There's no such thing as speed without a direction.
because velocity in and of itself is a meaningless concept.
So again, that's her terms. That's how she's using this bullshit rhetoric, this contrived word soup, to just make up silly. Again, how does this fool people? Do you really think, okay, that velocity isn't a real thing in the universe? Do you really think it's not a concept? Do you really fall for that?
You can only talk about relative velocities.
Yeah, you can talk about relative velocities, but they're not the only thing you can talk about. And again, acknowledging that two things share a velocity, okay, and that so relatively speaking, they're in the same condition, and that one of them changes from that condition, and that's the new thing you're going to measure is the change. You can accept the fact that they have a shared velocity, and even if they're going in opposite directions. And we already know that, yes, it really doesn't matter when they have contact. When there is contact, it's not going to matter whether, if it was kinetic energy, it would matter, right? If we're going to measure things based on kinetic energy, it matters which one has the energy when you have a collision. But if you're just using momentum, it doesn't matter. It doesn't matter whether the speeding bullet, it doesn't matter whether the particle of dust hits the spaceship at 10,000 miles an hour or the spaceship hits the particle of dust at 10,000 miles an hour. But it does matter if you believe in kinetic energy, because the kinetic energy of the spaceship going 10,000 miles an hour is gigantic, where anyway, the point is when you square there, you're just opening the door for a huge inequity in all collisions that wouldn't exist with just momentum.
Not absolute.
The point is the recoiling gun can hit the bullet, and that tug of war is not going to be won by the bullet. You could take the energy of the recoiling gun and you could crash that energy into the energy of the bullet, and there won't be any evidence that the bullet has 1,000 times more energy. There will be no evidence that the bullet substantially wins the battle, because it's 1,000 atoms going 1 mile an hour versus one atom going 1,000 miles an hour, and those two things are in fact the same energy. Oh, shit. It's pathetic that 350 years since Newton gave you the simple logic, and here you are just making a mess out of it.
Once. This is why Einstein's theories have the word relative in them.
Oh, that's not why, but whatever. The point is that somehow there isn't absolute space is the real argument. And again, it's so anti-Newtonian. Newton spent the whole first chapters of his book explaining, arguing against any notion of relative space.
This brings us to the third and most important point that we learn from the spring.
I mean, relative space as an absolute. That is, there's nothing absolute. Everything has its own condition and world that it exists in. Somehow you can separate all these things into frames where there's different rules. Newton said the rules are the same everywhere. Same rules apply. The same clock is ticking. The same everything is everything. The space is the same. The density, the everything.
Acceleration is not relative, it's absolute. You can measure how much you're accelerating.
So again, it's just so silly to say acceleration is absolute when you can be decelerating. So clearly the acceleration isn't absolute in any sense. Your acceleration can be a deceleration, and that won't feel any different than an acceleration except the direction changes. So again, just a nonsense statement. There's absolutely no evidence that acceleration is somehow absolute and velocity isn't. Just nonsense.
For example, with that spring, and you can tell when you're not accelerated.
So again, the whole point of telling, is the big, easy. I mean, it's just so easy to understand why one thing is different than another thing. I mean, these physicists know that you could break something into little pieces. You could break your body into little tiny pieces. All right, put them in space. And those collective pieces, as long as they now share the same exact momentum, the same velocity, the same direction of motion, they'll do exactly the same thing. They'll all move as if they were collective. Nothing will change because the forces that are going to act on it, these gravitational forces, are acting on the little tiny electrons and protons. They don't care about your big shape. They just care about your little shape, the stuff inside of you. And they're just pushing that. And that's what they're catching the wind of gravity with. And so if you don't change the amount of mass, you won't change the motion. How else to say this? I mean, every piece of matter, whether it's a 10-pound piece or a 1-pound piece, will move exactly the same increase in its relative speed. That is, it's all going to move 10 miles an hour or 15 miles an hour. Now, a hammer with 15 miles an hour is going to hit something with a lot more force than a feather with 15 miles an hour. Because it collects more wind because it has a bigger sail made out of its larger mass, but its velocity will always be the same. And just understanding, the point is you can't feel gravity because gravity is moving everything collectively. You can only feel things that do something different, not things that do the same.
We have a spring on a rocket in outer space. All right. What's this got to do with gravity? Well, this is where Einstein's genius comes in.
Oh, jeez. So, look, it's a good thing that, Einstein did, he's kind of famous for being a dissident in the end. 2 years before he died, he said, I've been studying photons for 50 years and haven't improved my understanding 1 iota. That kind of stuff. I mean, he was conceding that none of this is really working and it's all a bunch of gobbledygook. That was his opinion of it. Spooky mush.
Einstein said, let's put the spring in a box from which you can't look out. You have no idea what's going on outside. We tie the box with you and the spring to a rocket. The rocket blasts off. What happens? Well, the spring expands again. Einstein...
So she's attaching the spring to the top of the elevator and again talking about some expansion without a weight on the spring. So without the weight to give you a good reason to have to share a lot of velocity, you won't see much. I mean, the spring isn't going to be very illustrative without a mass, So you really should have the human at the bottom of the spring, and then you can make this argument. But obviously the human's going to feel the floor because the force isn't affecting it directly. There's no direct force. There's no direct connection between the rocket and the human. So the only connection is through the floor. So it can only get the force through its feet first, and it's not going to get the force in the form of the gravitational field, let's say, that existed and you were fighting.
Now said that if you're in the box, you can't tell whether you're being accelerated or whether you're...
So you can always tell when you're being accelerated. So I don't know exactly what her point there was. You're obviously going to tell that you're being accelerated as soon as the floor hits your feet. So that's not even close to a subject. And again, it's just the distinction between recognizing that the discrete force will affect the sensual, sensing human being different. So one of them, you can sense the earth pushing you back. You can't sense the gravity pushing you in. And it's that simple. There's nothing more complicated than that. But the forces are exactly the same in their magnitude. It's exactly the same collection of a quantity of motion, momentum.
Sitting still on the surface of a planet. He then said if there isn't any measurement that you can do to tell...
So again, this equivalency principle stuff is just based on a nonsense and some idea that things should look the same. So again, saying they should feel the same, saying they should look the same is being really ignorant, frankly. It's a juvenile physics mistake to make, that you can apply those standards to the mechanism, and it's easy to understand that they won't feel the same, and it's easy to understand what they look like. Okay, because you have some idea of meteors being bent, traveling around the earth, and then you suppose that somehow light will also be bent going around the Earth, by the force of gravity. Somehow a photon is capable of acquiring two momentums was a wrong theory in the first place. There's no evidence that light does curve, and so why would I expect it to curve in the spaceship? And the simple truth is, it doesn't. I mean, actually, I'll throw the illustration of this in, but it's almost like, oh, come on. There's no point. You shouldn't have to illustrate something so, basic. This shouldn't even be. This should be something everybody already accepts as truth, and that this experiment we can't do, and that's the unfortunate fact, is that we just can't do the experiment, but you can simply understand the logic that you have two problems. Let's make a light clock. Okay, so we're going to shoot light across the two sides of a spaceship, okay, and the spaceship's going to move in a direction. So the first problem we have is, okay, well, a photon is an event, frankly. It's made of a substance that flies in space that has a profile. We have a wavelength, all right? So there's a concession. It has a wavelength. So that means it has, it takes time to make one, okay? It occupies an amount of space, okay, that is time controlled. And so the first problem you're going to have is your surface is moving very fast, like half the speed of light, and you're going to shoot a photon. Well, what's going to happen is, well, a piece of your photon comes out here, a piece of your photon comes out here, a piece of your photon comes out here. So that's your first problem. Can you even shoot a photon? So to fix that problem, all right, the thing to do is to just put a hole in the spaceship. Okay, so then you can shoot a photon from out here, and it'll go through the hole. But you got to remember that the hole's moving. So you have to have your photon go through the hole at here, because by the time it finishes going through the hole, it's going to be down here. All right, so this is how your photon's going to look to the spaceship. So the spaceship's going to see the photon move. But obviously the photon's just going straight, and this wall's moving this way, and this wall's moving this way as it's going through. But the photon's making a straight path. It didn't do any of this. Okay, this difference is all an illusion created by the fact that you're moving the spaceship. So likewise, the target's moving. So the photon is in fact just going straight. All right, that's what the photon is actually in the real universe doing. And all the other shit is moving, okay, around it. That's all that's happening. All right, so there's no illusion that the photon is bent down, okay? So yes, if you're in the ship, you're going to see the photon go down. You're going to see this idea that it bent. If there's a laser beam and you could watch it, it's going to look like it hit the wrong part of the ship. It hit down here. The straight across was here, and it's going to hit down here. All that's going to happen as an appearance, but it can be understood that no, the photon went dead straight. You just traveled past being able to view it dead straight. You, with the ship, moved and changed how the photon looked. But that's all you did. You created a mirage. And I said, oh, look at the pen. There's a frame rate. Yeah, see, it's an illusion. There's no place where the pen is standing still. That's fake and phony and fraud. So anyway, yeah. I mean, when you have to do 5th grade physics, in an argument with physicists, it's just, you really shouldn't have to do that. Shouldn't be part of my burden here. Okay, so I want this back on, and I want this off. Continuing.
These situations apart, they're physically indistinguishable.
So they are completely distinguishable. They're completely understandable as two different mechanisms, all that kind of stuff. And it's just, again, creating these nonsense conditions that we're going to suppose, okay, you can't look out the window, you can't do something obvious to see the truth, okay, and you're just going to talk about what you feel. And that's just being, childish.
That is, in a small box, the effect of gravity on the surface of a planet is indistinguishable from acceleration in the absence of gravity.
So it's just nonsense that the two things are the same or indistinguishable, because they can be distinguished if you actually can do the experiment, and because you'll find that the speed of light was the same speed. The curved line is obviously a much longer line. Light would have to accelerate to travel that much longer line and land on the surface in the same time. So it's obviously there's no dilation of time. There's no you didn't go more distance in the same amount of time. None of that actually happened, and it can all be understood that none of that actually happened.
This is what's called the equivalence principle.
And it's just wrong, okay, because the forces are different. You're something imposing on some portion of your substance, and only that portion, is very different than some force like magnetism or induction or something else, some photonic, some discrete tiny force pushing through you. Those are very different things in how they're going to affect your matter.
The point where people usually go wrong is to
the point where people go wrong is they listen to douches and douchettes.
Conclude that because gravity is indistinguishable from acceleration, that means gravity accelerates you.
So again, and all gravity is doing, right, it's a force, and it shares its force with you. So just as the Mississippi River, I throw a boat in the Mississippi River. Well, the Mississippi River has to give away a little bit of its energy. It's not going to be, the water isn't going to be flowing quite as fast as it was if the boat wasn't thrown in the water, because it's going to have to share its energy. The same is true with gravity, okay? The imbalance is altered by the existence of you falling. So you're taking energy from a bunch of energy that actually exists, and there's just a differential. There's more of it coming down because there's no earth above you to absorb a bunch of the energy. And the absorption is temporary, but it's real. The fact is, the earth absorbs the energy and then radiates it. There's a time delay, and that time delay is what you're falling in.
But that isn't so, because to accelerate something you need a force, and gravity is not a force.
So she said again, gravity is not a force, it's just some magical thing. So photons aren't a force, they're just a bent geodesic, expanding out instead of expanding in. Are we supposed to believe that the bent geodesic hits you, okay, and reflects off of you? It's just terrible logic.
Einstein's equivalence principle says that you are accelerated if you sit still in a gravitational field.
You are constantly having your momentum altered when you're standing still in the field, because it means you're somehow compensating for the falling force, the differential in force between the universe's energy that's undiluted and the diluted energy coming through the earth. That differential, if you're not moving in it, it means something's stopping you from moving in it. And what's stopping you is that energy delayed. The energy that went into the earth yesterday is coming out today. And that fact is that's what's going to stop you, is that pressure. But you're still go in first. It pushes back. You go in. It pushes back. You go in. It pushes back, because gravity is a constant force, a constant differential.
This is because the only way to sit still in a gravitational field is to have a force acting on you that prevents you from falling.
There you go. And so you're in that condition. So in a sense, the constancy of gravity is sort of dependent when you're talking about, it always has to be created by a mass, and you have to recognize, well, the constancy sort of is a dotted line. It's a the gravity is only accelerating you one half of the time, and the other half of the time you're getting accelerated in the opposite direction.
For example, because that floor is pushing on you. But you can't tell this apart from being accelerated in the absence of gravity in a flat space-time.
So again, you can tell it apart. They're distinctly different things. The matter pushing you versus a force pushing you, different things. Different feeling events. Now it's the same energy, but you're going to feel it differently.
Imagine, for example, you're falling into a black hole.
Oh, so this is just terrible when they use these examples and start talking about all their, and she's doing it in such a non-technical way that she's, throwing away things that you know about black holes, which is, spaghettification and all that kind of stuff. So she's not even playing by the real rules of a black hole.
No, I don't mean YouTube recommendations. I mean
whatever. I don't mean YouTube recommendations. She talks about, what YouTube says is popular, what YouTube promotes. So it's understand it's a popularity engine. So it just depends on collecting a bunch of dupes on your hayride, and you'll be able to sell tickets. Okay, but if you don't have dupes on your hayride, you're never going to get an audience.
Literal black hole. You're in a box with your spring and without any rocket boosters and so on. The black hole curves space-time, and you can use the equations of Einstein's general...
Oh, just amazing. You can. Go ahead and try. That would be the argument, and see if you get a right answer. I mean, all this talk about Einstein's equations, they don't get accurate answers. Right? GPS doesn't do the math to figure out how to compensate. It just says how far the clock's off, and it goes like this and just changes the clock. It doesn't have to calculate anything.
Relativity to calculate what happens. They'll tell you that if you get too close to the event horizon, you'll inevitably cross it, and then you'll end up in the singularity.
So obviously Einstein didn't agree with a lot of that crap, so I don't know why she's putting Einstein's name on this crap again. But anyway, so obviously the whole point is that when you go across this event horizon, the gravity is huge. You're going to go through this, every millimeter of your substance is going to be under a different amount of gravity. You're going to get stretched and spaghettified, and all kinds of shit's going to happen. So it's all a pile of crap. But there's no such thing, okay? Anyway, so there's no singularities, there's no event horizons, none of that crap actually happens.
Which might not be there, but that's a different story.
So again, why are you using it as an example? So she couldn't just keep it as a reasonable example. She has to, turn the example into some bizarre bent geodesic that has no bottom. It's an infinite well. I mean, it's just bullshit.
The point for today is that your spring won't budge because there's no force acting on you.
So we know the spring will budge because all of these lines mean a different amount of force, and you crossed a whole bunch of these lines with different amounts of force, so different parts of you are being affected by a different amount of bent geodesic.
Gravity is not a force. This is what physicists mean by free fall in a...
Oh, brother. So now they're going to invent this idea that what a physicist invented free fall. I don't think a physicist had anything to do with inventing the words free fall. All right. I think it's just a description of the concept that there's nothing holding you up, there's nothing attached to you, there's nothing connected to you, and the fact is you don't free fall in atmosphere, right? Because you do collect a whole bunch of atmosphere underneath you, and the atmosphere eventually says there's too much mass moving for the amount of force being applied to you, so you cannot go any faster because the amount of stuff you have to move with each movement, with each increase in velocity, you have to move more matter, and you can't move that much matter with the force you're collecting. So you're out of luck. You're done going faster. You're done free falling. And obviously when you get anywhere close to that velocity, which is like 100 and something miles an hour for a human being, the wind, you're going to feel it, okay? It's not going to feel like free fall anymore. I mean, it's definitely going to feel like you're fighting something, okay? There's not going to be just I'm free falling, like if you could feel completely independent of space. So free fall in atmosphere isn't exactly the same thing as weightlessness in space. And they're not the same either. It shouldn't be implied that they're the same. Ugh, this is so irritating. Humans. Leave us continue.
Gravitational field. It means there's no force acting on you, so you're not accelerated. A zero-G flight is the closest you...
So it's just idiotic to say you're not accelerated, just as it's idiotic to say that we don't know that the astronaut, weightless, is in fact, okay, you just don't have the scale in the right place, but he's certainly not weightless, and he's certainly not moving. He's doing a lot of moving, okay, he has a lot of velocities, but he just can't feel any of them. A lot of accelerations. He's constantly having his momentum changed, and that's the definition, the direction of his momentum especially, changed.
Get to that on Earth, at least if you want to survive. The idea of a zero-G flight is exactly Einstein's...
So again, this is, who does she make these videos for, I wonder? Because they contain components where you think, geez, don't you think your audience already knows how this works? That you just fly the plane at the speed that gravity would give you, and now you're just, going as fast as gravity's going.
Elevator experiment. That if you're in a box whose floor is not pushing on you, that's the plane, then you can't tell whether you're in outer space far away from any heavy object.
Right, and the only reason why you can't tell is because of how the force is being applied to you. It's a discrete, tiny force. It's rays of force, okay, that are pushing you, not a brick, not a floor, not a material object. The force itself is hitting your matter directly. There is no conduit between it. There's not a piece of matter hitting a piece of matter. There's a piece of force hitting a piece of matter. I mean, this is, kind of another obvious distinction.
Objects where space-time is flat, or whether you're freely falling in a curved space-time. Physically, it's exactly the same. So the zero-G flight is indeed a good simulation for outer space.
Well, it's a bad simulation of free falling because you're got the atmosphere contained in a bubble. And so it's not going to be the same as free falling in the atmosphere. It's going to be very different from that because there's going to be no wind to feel. So, these little subtle things that give you a clue to what's going on. And again, this is a conversation with physicists, and I have to explain, it's not about what it looks like. It's not about what it seems like. It's not about what it feels like. All right? Science is more challenging than that.
And why is that? It's because gravity is not a force.
Oh, she says it again. So that's at least 7 times, right? Ugh. She's just preaching it, pushing it. God is God. Yeah.
In the plane, you're falling in a gravitational field, but there's no force acting on you.
Well, of course, the only reason why you continue to fall inside the plane is because there is a force acting on you, accelerating you, and you are going faster and faster and faster as you're flying in the plane in the downward direction.
Now, I sometimes hear people say that zero-G is a bad term because it suggests that there's no gravity, but of course...
Right, so and again, the point is zero-G means zero differential. So I have zero-G if I go to that particular place, between where the moon is and the Earth. So I go out, whatever it is, 80% of the distance or whatever, and I sit there, and the Earth will be pulling me as much as the moon will be pulling me. So obviously pulling, when the fact is the push into the moon will be the same as the push into the Earth in terms of the force because of the difference in distances. And I will clearly have no motion towards either one, not be accelerated. There will be zero force imposed on me that I can see. But I'm clearly not being unforced. I'm clearly being pulled towards the moon and pulled towards the Earth, and I'm going to be in that tension. And the fact that I can't feel it doesn't mean it isn't happening. The fact that I can't see it doesn't mean it's not happening. The fact that you cannot see your molecular bits going into the earth, and then the earth pushing them back out, throwing them back out, and then them going in, and it throwing them back out. The fact that you cannot see that movement, you certainly can still feel it, which should give it away. Should be enough evidence for you to get it that, yes, there is a conflict, at the point of your ass. There is a conflict in forces taking place. You should be able to figure out that something's happening. You're not in anything called a zero condition.
The curvature of space-time doesn't go away just because you sit in a plane. And that's right, but 0g doesn't mean zero gravity. The g is the local acceleration that you...
So I don't even know. I didn't know 0g had something to do with free fall. So that doesn't make any sense to me at all. I thought 0g was when you were in that condition where you have a velocity, you have something that's countering the direction. So the trick with orbiting the Earth is your velocity vector as you're going around the Earth is essentially changing, and you're getting the one motion is pushing out, the other motion, the gravity is pushing in, and so the two just eat each other up as you start changing your position.
You experience if you are at rest in the gravitational field. If you are on the Earth's surface, that acceleration is roughly 9.8 meters per square second.
Per square second? What does that mean, per square second? How the fuck do I square a second? What's the geometry for a square second? There's no such thing in the universe. There's no cube of velocity. There's no such thing, okay? There's no geometry allowing you to do this squaring of a second. It's just nonsense. It's not Newton's formula. So why did Newton go to the trouble, really, right? There's just no, the scientists of the past were just wasting their time because we were going to piss it all away on converting it back into a religion. I mean, it's 9.81 meters per second per 1 second. There's no way to square the seconds. It's not seconds times seconds. It's 1 second. You're going 60 miles an hour. It's 1 hour. It's not any number of hours. It's not squared hours. It's every 1 hour. Oh, so bad.
As you probably all learned in...
Oh, no, I see, that's the trick, okay? I guess I'm a little older than you. Guess what? When I was in school, they didn't square the seconds. There was 9.8 meters understood to be 9.8 meters per 1 second units of time. That's how it was taught to me. That's how, I was taught Galilean gravity. So, it wasn't a matter to even dispute that, twice the time, 3 times the time, 4 times the time, that was going to decide your velocity. Your velocity was going to double with time.
Kindergarten. Though, strictly speaking, this gravitational acceleration isn't constant. The acceleration...
So she leaves out all the nuance of how springs work, but then she wastes time talking about the subtle, tiny differences in the gravity, depending on whether there's a big pile of lead in the ground below you, or some other, you're on top of a mountain, or you're at the equator, or you're at the North Pole, because the Earth isn't exactly a sphere. Tiny differences, not even worth talking about in the context of this gravitational force.
That you experience on the surface of Earth drops if you go to higher altitudes, and it also slightly depends on what the ground is made of. This is why measuring this acceleration tells you something about the composition of Earth's mantle.
So why would that have anything to do with the bent geodesic? Is the kind of funny part. How does the bent geodesic know that there's lead in the ground? Come on. It has to learn that because some force is interacting with the lead in the ground and letting the bent geodesic know. Okay? So, I mean, it's all such, it's so bad. It's such bad science. This just make up this fake notion of whatever the bent geodesic thing is. It doesn't need to reflect light off anything. It doesn't need to call it up on the phone. She does this little phone joke. It doesn't need to do any of that stuff to somehow know how to create the proper amount of acceleration. And it knows exactly, and the knowledge is exactly consistent with if I just put a hole right through that planet. If I just stuck, if I did a measurement through the planet and figure out what its density of the material was, and somehow it knows exactly the whole path of an imaginary thing going through and testing it. That answer is exactly the answer the bent geodesic knows. So how does it know it without? Yeah, that's exactly how it knows it, because the bent geodesic is being made by a force. Oh, fuck. Oh, I just hate this stupid fucking ignorant planet.
But I digress. By the way...
Yeah, it's exactly. A complete digression, useless trivia. Your audience, I'm sure, is well aware of all of that crap, right? I mean, 90% of the audience, I'd say, right?
This video comes with a quiz on...
Oh, isn't that so exciting? I'm just so damn... Aren't quizzes just so much fun? I mean, it's so ironic that these physicists... I guess it's because they come from a teaching community and they just have some kind of teacher's perspective, and they just... I don't know how they don't realize that they were a kid once and they were in school and there was nothing more tedious than quizzes. I mean, it's just... Fuck you. Fuck you. Yeah, well, if you explain one more time, I'll memorize it, but I don't really have it quite yet. Don't be quizzing me on this shit, you fucker. I mean, it's just so annoying. It's like, I just don't even understand how, oh yeah, there's somebody who's really horny to take your quiz. Oh, I just can't wait. Oh, fuck you.
Quizwithit.com that lets you check how much you understand.
I guess she's just doing it because they invited her to do it and paid her to do it. So it's just about making money for Quiz With It.
Dude.
No one seems to know this.
Oh, fuck you. Alright, so I don't really get this part, but apparently it says something to do with her quizzing thing, that she's going to sit there and restate what she already said in the video. So she said the words, to come back
to zero-G flights. On a zero-G flight, your acceleration is indeed almost zero because you're not at rest with the surface of Earth. That's why it...
Yes, you're not... Yes, your fucking velocity, your acceleration, is nowhere near zero if you just make it relative to the Earth. So as long as you recognize the guy is getting closer and closer to the Earth as he's playing all these little farty games, and that the airplane's going to actually have to start going back. It's going to have to do a radical change in velocity, acceleration, and you're going to get smashed to the surface. So you have to be ready for the fact that, when the plane is done playing games, it's going to have to get back to reality, and one of those surfaces of that plane is going to smack into you pretty hard. Those are the realities. Anybody rational knows those realities, so why would they pretend I don't know that guy is falling towards the Earth at a faster and faster speed? Yeah, I do know that. Shit.
Feels like free fall. Of course, it's not exactly zero because you always move around somewhat that way or this way, or if you're rowing because you're doing CPR.
If you're rowing and you're doing CPR, what the fuck does it? It doesn't even make any sense. And what's this guy doing with this pillow thing? What the fuck? You got a prostate problem or something?
But it's pretty close to zero. So I'd say zero-G is a good description.
What the fuck is that? Anyway, yeah, pervertiverse, frankly, right? I mean, they're everywhere, the perverts. Oh, fuck.
Same thing on the ISS. Okay, but I can see you're still confused because you learned that acceleration is a change in velocity.
So again, these are just definitions. I don't know, you learn it. I mean, it's just so... it's just coherent language. So the only thing different about an acceleration is it's a change in velocity, but it's still just a velocity. You're just adding or subtracting velocity. It's not some kind of different thing. An acceleration isn't jelly to Velocity's peanut butter. No, it's the same thing.
And if you're not changing velocity, you're just standing on Earth. How can you be accelerated? Well, the entire point of Einstein's theory of relativity is that velocity...
So she's saying what the entire point is. Yeah, but yeah, look, there's no undoing that Einstein defended this piece of crap, okay, and it was crap, and I don't know, but I didn't talk to him, in whatever, 1955 or something or whatever, so I read a couple of very thick Einstein books, so I know a lot about his life, and unfortunately, there's just there's not a lot of great physics in it.
Velocity is not absolute. What you mean if you say you're not changing velocity is that you're not moving relative to the surface of Earth, but they still...
You're not moving relative to the surface of Earth. What does that mean? Okay, I don't know what that point was.
Doesn't mean you have zero velocity, because that's a meaningless statement.
So again, she's saying that somehow velocity is meaningless when it's always going to be a difference in velocity from our perspective because we don't have the universal to measure. I mean, we have it in the form of the photon. The photon does universally move in a straight line at a constant speed. And so it would give us a measure of position, but we have no way to, standardize that.
It just means you're not moving.
I suppose we don't have no way to do it. I'm just trying to think if, you can't even put you probably could put two satellites in space and just shoot a beam of light between the two satellites.
Relative to something else that accelerated the same way, which is the surface of Earth.
Just thinking, because they couldn't have any relative difference in their motion, but they could have a same motion. But yeah, if it's any kind of velocity, they're going to miss the light. So it would be an interesting thing to do.
You can, however, return to talking about Newtonian gravity by redefining what you...
I mean, laser beam would have to be a laser beam that somehow doesn't stretch over great distances, and that's the problem. Yeah, you can't shoot a laser beam to even the moon, I mean, the point is if you could actually shoot a laser beam to the moon, you'd have this perfectly straight line that you could measure everything else's motion based on. But it couldn't be any motion that was fast enough to change how the photon was created in the first place. But the problem is yes, the laser beams they shoot at the moon are gigantic. By the time the laser beam, the laser beam leaves Earth, being an inch wide, it gets to the moon, it's 3 miles wide.
Mean by no acceleration. In general relativity, as we've just seen, you are...
She didn't show anything. We didn't see anything. Just a bunch of nonsense about how because you can't feel the force didn't hit you, which is just nonsense.
Accelerated if you don't move relative to the surface of Earth, say because you stand on top of a building. If you jump and fall, you're not accelerated.
So there's no point, right, in this silly illustration, because the Earth is going to hit you, right? So if she's saying there's no acceleration, there's no velocity, there's no force that you have collected, then how does the Earth know you jumped off the top of the building? You could have just jumped 10 feet into the Earth. The Earth's going to smack you, okay, based on a momentum differential. And obviously you've collected a bunch of momentum. So there's just no frickin' point in talking about how the Earth is actually colliding into the astronaut, because the Earth isn't going to be able to figure out that he jumped off the roof versus he jumped out of the first story window. So it's just stupid. Stupid.
Because there's no force acting on you. If you hit the floor, you're very suddenly accelerated again, which...
Yes, you're accelerated based on your momentum that you acquired through the process of collecting the force as you were falling. And the Earth didn't push back at you catastrophically, okay, because somehow it knew you jumped off the top. How did the Earth know how high you fell from? Oh, that's right. It can't possibly know how high you fell from. So the only way you could have acquired a differential that will actually splatter, the only way you can splatter when you hit the Earth is that something has to have a momentum differential. And the only way you got that momentum differential is it collected a goddamn force. It collected quantity of motion.
Which has, well, measurable consequences. In Newtonian
Yeah, exactly. Measurable, exactly dependent on how long you're in the 9.8 meters per 1 second. So how many seconds you're in it will tell you exactly how much momentum you're going to acquire from it. Negating air resistance, of course.
Gravity, you introduce this new force that you call the gravitational force.
And what's new about it? So I don't even know. So having some idea, okay. So she says Newtonian gravity not accelerated. That's not Newton's physics. So we know that Newton knew you're getting accelerated because Newton believed that these kind of arguments about circular, spherical things and spinning things prove there's no relativity, because they prove that the phenomenon can't be created by some other mechanism. I can't blame something else for faking me or fooling me, because the event can only happen in one way. The force has to be applied to only one object, and if it's applied to other objects in the negative sense, it won't look the same. It won't act the same.
And say, if you're on top of the building, that force of gravity cancels that from the building pushing on you. So now there's no net force acting on you, and Newton says you're not accelerated.
Well, of course, you're not capable of being moved, gaining velocity from your accelerating, but of course you're being accelerated. His feet are still pushing into the building. The building is pushing into the ground. There's a ton of accelerating going on. It's just that the acceleration this way is countered by getting pushed this way, and then this pushes down, and then this pushes back up. But there's constantly a bunch of changing in your momentum. Your momentum is constantly changing. Pieces of you are constantly changing their momentum. You're not passively sitting there saying nothing's happening. And of course you know it because you can feel this one.
If you jump off the building, Newton would say, the force from below disappears and there's only the gravitational force acting on you.
Okay, so the force below disappears is kind of a bullshit statement because I don't think Newton went that far. You're just saying that now the differential, okay, isn't compensated by this object that's capable of pushing back. The matter can't push back because you're not connected to it. And it's not until you touch the matter, you know, like he's falling by the side of the building. If he stuck his hand out and touched the building, he could reduce his velocity. He could reduce the rate at which he's falling by sharing his motion with the building. And that's all it's about. It's about the contact. So if the contact is strong on top of the building, yeah, all of your velocity, all of your momentum will be absorbed by the building. And if it's weak, you're just touching the building, well then you only lose a little bit of your velocity.
And you're accelerated. And if you hit the ground, you suddenly return to zero acceleration. The Newtonian picture is...
So again, there wasn't any zero acceleration, and the puddle on the ground is not in any zero condition. It's jiggling in the gravity. It's pushing on the Earth is pushing it back just like it's doing it to you.
It's the one we learn at school, and it's useful so long as you are on Earth.
Oh, gee, it's just so insulting, you know, what they do to these icons. So someday in the future, I hope they put you in a little yellow Twadicus bus, and you know, they do all kinds of little things to animate you into a retard. Because that certainly will be what you deserve, is to not be treated with any dignity at all. I mean, they're just, you know, this isn't standing on the shoulders of giants. This is stomping on the shoulders of giants. This is stomping them into the ground. It's cheating them grotesquely.
But strictly speaking, it's wrong.
I mean, Newton didn't have a sense of humor. So there's no chance he'd find it all fun and interesting. No.
Because you can't just redefine what you mean by zero acceleration.
No, so again, there's no redefining. It's just this obvious 9.8 meters of velocity, per second velocity will be acquired every 1 second. Where's the redefinition? There's no redefinition. It's being acquired because you're in a constant wind, okay? And your mass is the sail. It's collecting the wind. So the more mass you have, the more wind you collect.
You can't do that because acceleration is not a relative quantity. If you're staying in place in a gravitation...
It's not a relative... I'm just saying, it's a velocity. Of course, it's always going to be stuck being relative because we can't know what our shared condition is. So we can never give absolute numbers. But the absolutes are irrelevant because all we want to know is how much money is going to get exchanged. We don't want to know how much is in their safe. We just want to know the differential. He has $10,000 in the safe. He has, $10,000 in 10. The only thing we want to know about is the 10. We don't care about the 10,000.
Field, so you aren't falling, then you are not at zero acceleration, as any accelerometer will tell you. Now, of course, physicists are no linguistic saints, and there are some...
Oh, yeah, whatever. You just committed a whole bunch of linguistic crimes, pointing out again how the accelerometer, blah, 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 is the mechanism for telling you what's happening when obviously it's deeper than that, in the sense that the accelerometer can't tell the difference either. If it can't feel the force, so to speak, it doesn't think it exists either.
Times refer to gravity as a force, even though it isn't. A typical example...
So, of course, it is. You didn't make any convincing or real or substantial arguments demonstrating how it's not a force. So there was no moment where she said a single thing that can't be argued as, well, why couldn't a force do that? Why couldn't a force do that? Why couldn't a force do that? There was no explanation for why a force isn't a good explanation.
When they speak of the 4 fundamental forces of nature. If they're being careful, they'll refer to it as the gravitational interaction.
Yeah, yes. Everything's an interaction, so, what's the point? The idea was recognizing the interactions caused by the discrete moving at the speed of light stuff versus interactions between matter having a quantity of motion and another piece of matter having a quantity of motion. There's a sort of a concession in physics, I don't know if you're aware of it, that there's this distinction between the forces and the matter. That there's 2 kinds of stuff in the universe. Force, matter.
And the 4 fundamental interactions. But often they don't. I think they really just call it a force because that starts with an F.
No, they call it a force because it obviously has it quacks like a force, it has feathers like a force, it has a bill like a force, it has, loose poop like a force, it has webbed feet like a force. It has all of the fucking features of a force. That's why it's called a force. It's moving the speed of light. I mean, all of it. Every one of the features it has.
In a nutshell, why is gravity not a force? Because
Einstein said so. And I don't know if Einstein actually did say so. So again, shit. I think Einstein conceded, frankly, from what I understand in letters, that, the bent geodesic has to be made out of something. There has to be a mechanism. It can't just, spooky gravity. There's no spooky gravity.
if you are only exposed to the gravitational interaction, you fall, and that is measurably not an acceleration.
So it just doesn't make any sense. You fall, and that's measurably not an acceleration. And again, by what kind of silly measurement? Because certainly you can watch it accelerate relative to the Earth. So, you can watch space shuttles break into little fucking goddamn pieces.
If you need to freshen up your knowledge of forces and Newton's laws before taking on Einstein's ideas, the best place to start is brilliant.org.
Brother. So, Brilliant finances all this propaganda. all over the YouTube net. It's all being, sponsored by, this pervertiverse engine of nonsense that hasn't been demonstrated to be the truth. A bunch of fables. It's just a religion, sadly. And the fact that science won't put itself up to more rigorous scrutiny is like the politicians and the rest of it, right? If I was a politician, if I was the president, the first law I would pass is that any government employee, who breaks the civil laws pays at least twice the penalty, maybe 3 times the penalty. Because there's just no excuse. You're going to be a public servant and you're going to be a thief? Fuck you. Okay? That's a big crime. That's a crime against every single human being on earth. To corrupt and break the only thing that can give them any hope of having fairness and merit pay and all of that crap. The only hope of having a deserved economy or a deserved civilization is honest civil servants. And scientists should have the same attitude. They should want their science tested. They should be hungry to be tested. They should sit there and say, guess, throw your shit at me and I'll defend. Because I have something worth defending. And because that's just a religion. And just like the religious cowards, they just hide behind, I'm entitled to have my faith. And they just pretend they're not a cabal of whatever 500 people who get to tell everybody else what the truth is. It's just such a pile of crap. And the fact that you dupes, you suckers, you fools, fall for it. Bad on you. Bad on them, but bad on you that this crap fools you. Ugh, this unevidenced crap. You should be saying, show me, show me, show me. Show me it taking 25 times the fuel to move something 5 times as fast. Show me! That's what you should be saying.